Okay, so in this video, we're going to talk a little bit about rectilinear motion. We've already talked a little bit about it earlier in class, but now we're also going to use the information we've just learned about finding maximums and minimums to do more with these types of problems. So first, let's recall. If S of t is the position of an object, at time t, then the velocity of the object is given by v of t, which is the first derivative of position, and the acceleration of the object is given by a of t, which is the second derivative of our position. So these are the definitions that we've been working with before, and now we're going to talk more about what's going on in velocity and acceleration problems. If our velocity happens to be a positive number, we say that the object is moving in the positive direction. And if the velocity is a negative number, we say the object is moving in the negative direction. So that means that velocity gives us a couple pieces of information. It tells us what direction the object is moving in, and it also tells us the rate that the object is moving at. So what if we didn't really care about what direction the object was moving in, we just wanted to know how fast it was going? We would need to define a speed function. So first I'm going to write down what we just talked about. When the velocity is positive, the object is moving in the positive direction. And when my velocity is negative, the object is moving in the negative direction. And of course, when the velocity is zero, that just means that at that instant in time, the object's not moving anywhere. It's staying in place. So we are going to define the speed of the object to be the absolute value of the velocity function. So that will tell us just how fast the object is going, and it will obscure the information about what direction the object is moving in. So let's just start with a nice example. We're going to write down a position function, and we're going to find the velocity, acceleration, and speed functions for that object. So let's let S of t equal t to the third minus 6t squared, and that's going to be the position function of a particle moving along an s-axis. Where s is in meters and t is in seconds. We want to find the velocity, acceleration, and speed functions of this particle. All right, that's not too bad because we know that the velocity is equal to the derivative of our position function. The speed is going to be the absolute value of that velocity. And then my acceleration is the second derivative of position, which just means it's the derivative of velocity. So we just have a couple derivatives to calculate, and then we'll be done with this particular example. I'm going to leave my S of t written down up there at the top. And let's find our velocity function. So since our velocity is equal to the derivative of position, we have that the velocity function is equal to 3t squared minus 12t, and we got that just by taking the derivative using our power rule. Well, then I know that my speed is equal to the absolute value of velocity. So I would just have the absolute value of 3t squared minus 12t for my speed function. And my acceleration, which is equal to the second derivative of position, which would mean it's the first derivative of velocity. We can find our acceleration function by taking the derivative of our velocity. And that is another power rule. So I would just get a 6t minus 12 for that acceleration function. All right, that's pretty straightforward. But now we get to do something a little more complicated. You might think that a positive acceleration would mean that the object is speeding up, and a negative acceleration would mean that the object is slowing down. And that makes some sense, except unfortunately it's not true. Because what if you had your velocity was already negative, and then you had a positive acceleration? Is the object actually speeding up? Well, if I had a positive acceleration, then we'd be moving in the positive direction for my velocity, which means in absolute value, my speed has gone down. That's a little confusing to think about, but that's why we make sure we specify what it means to speed up or slow down when we're talking about this rectilinear motion. So we say that the object is speeding up when the speed is increasing, and this happens when our velocity and acceleration have the same sign. So what does that mean? It means it does not suffice to just find where the acceleration is positive to determine where the particle is speeding up or slowing down. You have to actually compare the sign of the acceleration to the sign of the velocity. So if you have a positive velocity, the object is going to be speeding up when the acceleration is also positive. And when you have a negative velocity, the object is speeding up when the acceleration is also negative. Similarly, we say that our object is slowing down when the speed is decreasing. And this happens when velocity and acceleration are of opposite sign. So what does this mean? It means if our velocity is positive and the acceleration is negative, then the object is slowing down. And also, if the velocity is negative and the acceleration is positive, the object is slowing down. So let's go back to the example we were already working with before and figure out when that particular object is slowing down or speeding up. So we're going to use the same position function as before. So the position function was t to the third minus 6t squared, and we want to find when is the object speeding up or slowing down. Well, to do that, I need to find out when my velocity is positive or negative and when my acceleration is positive or negative. We had earlier that my velocity was 3t squared minus 12t. To figure out where this is positive or negative, first we should find where it's equal to 0. If I factor this, I can pull out 3t, leaving a t minus 4, and I get that my velocity is 0 when t is 0 or when my t is 4. So I know my velocity is 0 at those two instances, and now to figure out where it's positive and where it's negative, I just have to check values in my velocity function on each side of these critical values. So I'm just going to remind us, the velocity when we had it completely factored was 3t times t minus 4. And we just found that the velocity was 0 when our time was 0 and 4. And so I want to check numbers on this number line on either side of my critical values to see if my velocity is positive or negative. Except I actually do not need this side of my number line because negative time does not make sense in the real world. So I just need to check values in this subinterval between 0 and 4 and over here where we're bigger than 4. Does not matter what values we check, so pick some easy ones. I would try plugging in a 1 and plugging in a 5. So if I plug 1 into this velocity function, 3 times 1 is positive, 1 minus 4 is negative, positive times negative is negative. And when I plug my 5 in, 3 times 5 is positive, 5 minus 4 is positive, positive times positive is positive. So I get a sign chart for my velocity function. My velocity is negative, meaning that my object is moving in the negative direction between 0 and 4 seconds. And then after 4 seconds, my object has switched to moving in the positive direction, and it keeps moving in that direction forever. So this is my sign chart for velocity. Now we need to make one for acceleration as well. Remember that our acceleration function, which we had from earlier, was 6t minus 12. If we find where this is equal to 0, I get that my t is equal to 2. So making a number line for my acceleration function, here at 2, I need to check values on either side of the 2. So I'll check a 3 over on this right side, and I'll just check a 1 over on this left side. If I plug a 1 into my acceleration function, I get something negative. And if I plug 3 into my acceleration function, I get something positive. So I get a nice sign chart for my acceleration function. And now we know that my object is supposed to be speeding up when the velocity and the acceleration agree with each other in sign. And my object is going to be slowing down when they have opposite sign. Now, it might be a little difficult to look at it when you have it on 2 different number lines. So I would suggest you draw one number line and put all of the information on it. So I'm going to draw one number line, and I'm going to put my important values on that number line. We had 0 and 4 for the velocity, and we had a 2 for the acceleration. Those were our important values. I'm going to put the velocity sign chart on the top, and I'm going to put the acceleration sign chart on the bottom. Now, from what I just erased, we had that our velocity was going to be negative between 0 and 4, and then it switched to positive after 4. So my velocity is negative everywhere between 0 and 4, and then it's positive after 4. My acceleration was negative until we got to 2, and then after 2, it was positive. So now we can see where our object is speeding up or slowing down. Remember, our object is speeding up when the signs of the velocity and acceleration functions agree. I can see that they're both negative between 0 and 2. And then they're both positive between 4 and infinity. So I have that my object is speeding up between time 0 and 2, and then at time 4 going on forever. And then my object is slowing down when the signs are opposite of each other, which would just be between 2 seconds and 4 seconds. All right, so that wasn't too bad, trying to figure out where it's speeding up or slowing down. And I just have, believe it or not, just one more example for this video, where we end up using some of our skills from previous videos to find the maximum speed of a particular object. So an example. Find the maximum speed of an object with position function s of t equals 2.5 t squared minus 17t, where s is in feet and t is in seconds. Over the interval t between 1 and 5 seconds. So the first thing that we should notice when we look at this problem is we're trying to find a maximum. And we've learned all about how to find the maximum and minimum values of different functions. But I want the maximum value of my speed function. So I need to figure out my speed function before I can do anything else. After I have that speed function, I'm going to find its critical values. And then, since we have this interval here, which is a closed interval, we're going to use the closed interval method for finding the max or the min, which means we would have to plug our critical values into our speed function and plug these endpoints into our speed function. Whichever one gives us the highest result is going to be our maximum speed. So first, let's find that speed function. So our position function was 2.5 t squared minus 17t. And I know that my speed function is the absolute value of my velocity. So let's find the velocity first. My velocity is the first derivative of my position. So using my power rule here, I'll have 2 times 2.5, which is 5, t, and minus 17 as my velocity function. That means that my speed function is the absolute value of my velocity, the absolute value of 5t minus 17. Now this is the function I'm trying to find the maximum of. The problem is absolute values are kind of tricky because they equal different things depending on if it's positive or negative inside the absolute value. What I mean by that, if my 5t minus 17 happens to be positive, well then my speed is going to be equal to 5t minus 17 because the absolute value of a positive number stays positive. So if I have 5t minus 17 as positive, then I can find the derivative of my speed. So I'm just going to call that speed prime is going to be 5. That doesn't have any critical values because 5 is not going to be undefined and 5 is not going to be equal to 0. So no critical values. Similarly, if my 5t minus 17 is a negative number, well then my speed, which is the absolute value of that negative, would be the positive version. So that's going to be negative 5t minus 17, because we're saying 5t minus 17 is negative, so negative of that would make it positive. This means that my speed function looks like negative 5t plus 17, and so my derivative, speed prime, is equal to negative 5, which also has no critical values. The question though is, what happens when 5t minus 17 is equal to 0? Well, when I approach that from the right side, it looks like my derivative should be 5. But when I approach it from the left side, it looks like my derivative should be negative 5. That means my derivative does not exist at that point. Remember, the graph of an absolute value function looks like a V. And we know that a function is not differentiable at a sharp corner. So it's at that point that we have a critical value. So when 5t minus 17 equals 0, our derivative of our speed function does not exist, because that is where we have that corner. So when is 5t minus 17 equal to 0? Because that will give us our critical value. 5t minus 17 equals 0 when t is equal to 17 over 5, which is 3.4. So that is my only critical value. It's a critical value because my derivative does not exist at that particular value of time. So now to find my maximum speed, I have to plug this critical value into my speed function, as well as checking the endpoints of my time interval. Whichever value gives me the highest result will be my maximum speed. So let me write down again what our speed function was. Our speed is the absolute value of velocity, so that's absolute value of 5t minus 17. I need to check my speed at my critical value, my speed at my left endpoint, and my speed at my right endpoint to see what we have. When I plug in my critical value, I get the absolute value of 0, which is 0 for my speed. When I plug in the left endpoint 1, I get absolute value of 5 minus 17. Well, 5 minus 17 is negative 12, but the absolute value of that is 12. And then when I plug in my 5, I'm going to have 5 times 5, which is 25, minus 17 inside of absolute values. And so that gives me absolute value of 8, which is 8. I'm wanting the maximum speed, so I look for the largest output, which is this guy here at 12. My maximum speed is going to be 12 feet per second, and that happens after 1 second has passed. So my maximum speed was 12 feet per second, and that was at time t equals 1 second. Now, even though they didn't ask us, we already did all the work to get the minimum speed as well. So I'm just going to answer that. Our minimum speed we saw was 0. 0 feet per second. At our critical value, it was time t equals 3.4 seconds. So all that means is that our object was moving at every other time, but at 3.4 seconds, it was temporarily still and gave us our minimum speed of 0 feet per second. All right, so this is how we deal with velocity, acceleration, and speed problems where we still have to find maximums and minimums using our previous information from previous videos. Let me know if you have any questions. You can leave a comment down below. If you are a current student of mine, you may also ask questions through email or in office hours, and I will see you guys the next time.